Good evening. Today we will see continuing course today zero order reaction. Okay, what is the meaning of zero order reaction? See carefully. For example, you are taking one chemical reaction, reactants are converting into products. Okay, for example, I have written for this rate law. Okay, according to rate law, what happening? R is equals to rate constant into concentration of reactant power Z. The sum of the powers only we are calling as a order. That's why here how much is the zero order reaction means. Okay, if we can take here one more step, anything power zero, concentration of reactant power zero, it is nothing but anything power zero is becoming like 1. Then R is equals to coming which one? K. So from this what we can tell, the rate of reaction is depending upon concentration of the reactant? No. So such kind of reactions only we are calling as zero order reaction. Zero order reaction means a reaction in which rate of reaction is independent on concentration of the reactant is calling as zero order reaction. Means anyway the speed of the reaction is not depending upon concentration of the reactant is calling as zero order reaction. Yesterday I given a talk some example, general example, but if you can see according to chemistry some equations. First one, if you take H2 plus Cl2, what we are getting? 2HCl we are getting. This is not happening naturally. How much H2 and Cl2 will be there? The reaction will not be proceeding. Means the reaction will be influenced by some other factors like sunlight. If you take sunlight, then only the reaction will be proceeding. That's fine. The whole reaction will be depending upon sunlight, but not on concentration of H2 and Cl. That's fine. We can write rate of reaction is equals to rate constant into concentration of H2 power 0 and Cl2 power 0. Anyway, some of the powers will be also equals to 0. Can I give one more example for this one? 2HI decomposition like H2 plus I2. This is also not happening. You have 10 liters of HI but not giving H2 and I2. Means what? The speed of the reaction is not controlled by HI concentration but controlled by one of the catalyst is nothing but gold. If gold is there, then only reaction will be proceeding. Means the speed of the reaction is not controlled or not affected with concentration of HI. Then we can write R is equals to rate constant into HI power. What is coming? 0. Can I give one more example for zero order reaction? For example, if you take 2 NH3, 2 moles of ammonia is decomposing like actually N2 plus 3H2. If you take like that, if you can take a big tank of NH3, it won't converting into N2 plus H2 basically means the speed of the reaction is not controlled by NH3 concentration but affected by one of the catalysts is nothing but platinum. If platinum is there, then the reaction will be good. That's why the speed of the reaction is not affected by concentration of ammonia, so its power is coming as 0. These all are calling as zero order reaction. Is important for Konnurs question. What does it mean? A reaction in which the speed of the reaction is independent of concentration of the reactant or not dependent on concentration of the reactant is calling as zero order reaction. It may affect it with some other factors like it. And one more important point we are learning here under order, it is nothing but pseudo first order reaction. Pseudo first order reaction. Okay, already you have some idea regarding pseudo, not perfect, some false. Octet configuration, pseudo octet configuration. Octet configuration is exactly having 8 electrons. Pseudo octet configuration is what? The elements which are having 18 electrons, its valence usually is calling as pseudo. Pseudo means not perfect. Some deviation will be there. So, what is the meaning of pseudo first order reaction? You see carefully, I will tell 2 statements is very important. Is a reaction appearance like higher order reaction may like second order or third order but follows which one? first order kinetics. First order. Such reaction is calling as a pseudo. Pseudo means what? It is not originally, is not perfectly first order. Means that's what we are telling. A reaction which is appears like higher order reaction but follows a first order reaction. Such kind of reaction is called as pseudo first order reaction. I will tell you one more condition here. If any reaction will be pseudo first order reaction means out of two reactants, one should be very lesser quantity. One should be very lesser amount, or nothing but very lesser quantity, or nothing but amount. Then it is called as a pseudo first order. All of you getting that? It is a chemical reaction. Just by seeing we can feel it may be second order or third order, but practically it is undercomes like a first order reaction. I will explain that one. And when it is possible, out of the two reactants, any one reactant should be very lesser amount. Just I will explain one thing. First of all, you have to take one example. CH3, COO, CH3 is undergoing hydrolysis. Okay, what happening here? Between carbon and oxygen bonding is shifting towards oxygen, we are getting minus here plus. From H2O what we are getting H plus OH minus. What happening? You know, H plus particle is attacking on minus, OH minus will be attacking on CH3 plus. Then what we are getting? CH3COOH plus CH3OH will be coming. Okay, ready. Now my question. Initially, first you study that information. What is the meaning of this one? 1 mole of ester will be combined with 1 mole of water. We are getting 1 mole of acid and 1 mole of alcohol. But what is the condition has to be taken? Out of the two reactants, any one reactant should be very lesser amount. Okay, you see carefully. For example, I am taking 0.01 mole of ester. 1 mole of ester will be combined with 100 moles of the water. 100 moles of the water. Then you have to study the reaction. You see, compare with 100 moles, 0.01 moles means almost negligible. That much large comparison not taken. See, work over here concept. It is nothing but CH3, COOCH3 plus H2O. We are getting CH3COOH plus CH3OH. Okay, what you are taking now? We are taking 0.01 mole and here we are taking 100 moles. So initially is there any products? No, 0. This is the situation at the starting of the reaction. Okay, after some time, I taken like this and left some time. After some time, finally, what we can observe? See very carefully. 1 mole of ester will combine with 1 mole of the water. So automatically, what happens? 0.01 mole is totally consuming in the reaction. Then it is becoming finally 0. From here, how much is consuming? 0.01 is coming. Remaining is how much? 99.99. And how much products will be getting there? 0.01 and 0.01. Why? Because 1 more. All of you. Okay. After some time, there is no reaction. Why? Means the total speed of the reaction is 0. There is no reaction. Almost speed of the reaction will be 0. Why? See, why there is no further reaction? There is no ester. Yes or no? Even though water is there, but is it any helpful to proceed the reaction? No. Means the total reaction is controlled by ester or both or water. Only ester. So actually, by seeing what we can expect, it may be second order, ester power 1, water power 1. You are maybe expecting second order, but follows first order reaction. That's why we can take R is equals to K into concentration of which one? CH3COO, CH3 power 1 is coming. So appearance may be like a second order, but follows which order? First order. Okay, just for understanding, I will give you one more example. Inversion of sugar. Inversion of sugar means what? C12H22O11 plus water. What we are getting? Glucose and fructose we are getting. C6H12O6 is nothing but glucose, and we are getting same formula C6 is equal to O6 is nothing but fructose. Here aldehyde function group, then keto function group, right? It is not a matter to us. Okay, same concept we are taking here. Initially, I am taking 0.01 mole and I am taking 1000 moles of the water I am taking. Initially, is there any product? No, 0. Okay, reaction is going on. After some time, there is no reaction. Is that our forward reaction will stops? Why? Yes, after some time, means finally what I observed, what happening? 1 mole consumes 1 mole, then 0.01 mole consuming in the reaction, finally it will be 0. From here, how much has to be consumed? 0.01, nothing but 999.99. And how much product will be forming? 0.01 and 0.01. There is no further reaction. Why? There is no sugar. Means there is no sugar means what happening there? The total speed of the reaction is controlled by sugar or water or both? Only sugar. Why? Because there is no sugar, there is no reaction. That's why the total, even though two reactants will be there, the whole reaction speed is controlled by only sugar. So that's why R is equals to K into concentration of the sugar power 1. So anyway, it is nothing but which order? Pseudo first order. But appearance is how? For 1 plus 1, second order. Appearance is like a higher order but follows first order reactions. Such reactions only we are calling as pseudo first order reaction. Your condition is what? Out of the two reactant, any one reactant should be taken very less amount. That lesser amount can be only control the total speed of the reaction. That only will come like power 1, it is nothing but pseudo first order. Okay, we will see one more small concept of molecularity. What is the meaning? Already just now we computed order and different types of order, zero order as well as pseudo first order reaction. Now we are discussing one more small concept, molecularity. What is the meaning of molecularity? We will see. First, I will write the definition. It is nothing but number of reactants which are involving in effective collisions to give the products. I will explain everything very clearly just once you see. What is the meaning of molecularity? Number of reactants which are involving in the effective collisions to give the products. Only one question I am asking: how reactants are converting into products? Okay, the reactant will have sufficient energy, no problem. Otherwise, they are absorbing energy by heating or nothing but different factors. Okay, by that supplying energy, what happening? The kinetic energy of reacting particle will be increasing. After increasing the kinetic energy, the reacting particle will be involving in the collisions. If those collisions are going effective means what? If they are having more kinetic energy, then only the reactant will be colliding with high speed, then they will be break down and recombine and converting into products. I will take one simple example. If you take two particles with 5 kilocalories energy, okay, those reactant will not give the products. If the same reactant will collide with 50 kilocalories energy, definitely they are converting into products. These collisions only calling as effective collisions, these are calling as normal collisions. Why here? Yes, they are having some kinetic energy. With that kinetic energy, they are involved in the collisions, but useless. Why? In that collisions, the reacting particles is not undergoing the breaking. But here, reactants are having more kinetic energy, means more speed. Whenever they are approaching together with high speed, definitely the reacting molecule will be undergoing the breaking into atoms. Then they will be recombining and converting into products. Whenever these collisions is happening, those only we are calling as effective collisions. That's why I am telling here, see, number of reactants which are involving in effective collisions to give the products is calling as molecularity. Molecularity may be 1, 2 and 3. Full stop. Molecularity may be 1 or 2 or 3. I will explain why I have this. So this molecularity will be means is nothing but theoretical value. But we discussed the order is the experimental value. And if you see here, this is molecularity concept is applicable for elementary as well as complex. But in case of, this is very important point. In case of complex reactions, molecularity is meaningful for every step, but not for whole reaction. What I'm telling, every word has meaning here. See what I'm telling, number of reactant which are involved in the effective collisions to give the products is calling as a molecularity, maybe 1, 2, 3, that's it. And molecularity is the theoretical value, just theory by theory we can get it, no need to do any experiment. In case of complex reaction, molecularity is meaningful for every step but not for whole reaction. Okay, how is that one? I will explain to you. See here carefully. For example, you have one of the example, ammonium nitrate. NH4 and NO2 is there, is decomposing like N2 plus 2H2O. Okay, here only one molecule is there, that too going in elementary step, that's why the number of reacting molecules will be calling as molecularity, that's why it is calling as unimolecular reaction. Unimolecular reaction. We use this concept in SN1, SN2 mechanism. SN2 is a bimolecular and SN1 is a unimolecular. If you see one more example, H2 plus I2 gives rise to 2HI. In this chemical reaction, how many reacting molecules is involving? 2 molecules, that's why it is calling as bimolecular reaction. Okay, if you see one more example, 2NO plus O2 gives rise to 2NO, 2 is there. Here, how many molecules are involving? 2 NO molecules and 1 oxygen molecule. Number of reacting molecules which are involving in the effective collisions to give the products only we are calling as a molecularity. How much molecularity? Trimolecular reaction. Trimolecular reaction. Okay, till here you got it. Now I am explaining very nice concept. You see, for example, 3 moles of A and 1 B is gives rise to D. So how you tell molecularity will be 4? Meaningless. Why? One thing you have to observe very carefully. If any one molecule is involved in a chemical reaction, we are expecting 100% accurate product. No, if 2 members are involved in the collision, nothing but fighting, then it is going effectively. Why? Because the collision between 2 members only. Then definitely we are getting expected product. No, 3 members at a time is involved in the fighting, then we can decide who will win. Why? Because very clarity will be there. But at a time we are only involved in the collisions, 4 molecules. Okay, is it any chance to identify the exact means who person will win? No, some clumsiness will be there. Means what? Means among the persons some unwanted collisions will be going on. Means whenever number of reacting molecules will be more than 3, among them some unwanted collisions will be going on, means ineffective collisions will be going on, in that some clumsiness will be happening in the reaction, that's why you may not get expected product. Definitely whenever more than 3 molecules is involved in the reaction, we should be going in which way? Complex reaction. Here how many are there? 4 are there, definitely going in complex reaction, you have to remember carefully. Okay, what is the first step? For example, 2 moles of A plus B gives rise to C. Okay, again one more step is nothing but A plus C is gives B. Is it clear? Yes, what we are getting? 3A plus B gives rise to D. Whole reaction we are getting CC cancelled to B. In case of complex reaction, what I am telling? Molecularity is meaningful for every step, but not for whole reaction. Are we telling molecularity is for? No. This molecularity is not meaningful for whole reaction, but meaningful for every step. What is the molecularity here? Molecularity will be how much? 2 moles of A and 1 molecule of this one is nothing but trimolecular reaction. Here what is the molecularity? 1 molecule of A, 1 molecule of C is nothing but molecularity will be is equals to 2. But we can say molecularity is 4. No. Why? It is a complex reaction. In case of complex reaction, molecularity is not belongs to whole reaction, but it is belongs to atoms. Are you getting it? So simply you have to remember one thing: whenever in the chemical reaction more than 3 reactants is involved in the reaction, it should be going through complex reaction. Then we can find out the molecularity for every step, but not for whole reaction. This is very important. But ordering is a meaningful for whole reaction. Are you getting it? Yes. Now I am discussing one small and important concept for 1 mark as well as competitive 1 mark. Units of K. Units of K. K means what amount? Rate constant or velocity constant or specific reaction rate. Okay, you take one of the chemical reaction, reactants are converting into products. Can we write the rate law? Rate law. According to rate law, what we can tell, R is equals to some constant into concentration of the reactant power 1. No, we can't expect. That's why take it as a here 1 will be there. It may come or may not be coming. That's why we are taking one common number here. Okay, in the rate law, powers of reactant means is N is also calling as which one? Order of reaction. Are you getting or no? N is nothing but order of reaction. Why? Because according to definition of the order in the rate equation or rate law, some of the powers of the reactant terms only calling as order. Now, what do you want? Units you want. Work out on units. Very important. Okay, what is the order units here? Rate units. Rate means what? Change in concentration by time. Numerator is coming to concentration. Denominator is coming time. Is equals to K. Square bracket which indicates concentration power. What is coming? N. You want to get the K units. K units is what is coming? Concentration by time into concentration power n. Okay, can we simplify here? A power n by A power n. A power n minus n. So we are getting concentration power 1 minus n into time inverse. So what is the common form units for the rate constant? Concentration power 1 minus n into time inverse. But here n is equals to what? Order of reaction. How it is helpful, I will explain. For example, you are taking n is equals to 0. What do you mean? Order will be 0. It is nothing but 0 order reaction. In case of 0 order reaction, what are the units of K? Very simple. Write out concentration power 1 minus n is 0 into time units. Anyway, 1 minus 0, 1. So anyway, concentration power 1. What are the concentration units? Concentration units is what? Mole, liter inverse and time inverse. Mole, liter inverse and time inverse. No, you are taking n is equals to 1. Nothing but which order? First order reaction. If first order reaction is there, what are the units of K? Concentration power 1 minus 1 into time inverse. 1 minus 1, 0. Anything about 0, 1. So only units is coming in time inverse. Now if you take n is equals to 2, it is nothing but second order reaction. Second order reaction means what? Units of K is equals to concentration power 1 minus 2 into time inverse. 1 minus 2 means minus 1. Minus 1 means is nothing but concentration power minus 1 into time inverse. Concentration power minus 1 means what? Mole per liter whole power minus 1. It is coming like that. Mole inverse. Yes or no? Liter and time inverse. Sir, how it is useful for us? In problems, yes, very careful and also. From units of K, we are getting which one? Order of reaction. If you given K value, definitely will give the units. From the units of K, we can get it order of reaction. Whether it's 0 order or first order like that. For example, in one problem, K value given as 0.5 into 0.5 second inverse. Is it which order? You can tell it. Rate constant units is coming nothing but time inverse. Time inverse is a unit for which order reaction? Yes, we can immediately we can identify it is a first order reaction. No, even K is equals to 2.5 into 10 to the power of minus 6 mole, liter inverse and minutes inverse. Mole inverse minutes inverse is nothing but which order reaction? Zero order reaction. Zero order reaction. No, given one more K value given, K is equals to 2.57 into 10 to the power of minus 4 liter mole inverse and hours inverse. Liter mole inverse and hours inverse is under terms which one? Liter mole inverse time inverse is a which order it is? Second order reaction. That's why from the units of K we can tell is a which order reaction? Second order. He will give, in board examination he is giving like this, he will give the K value, it is under the switch order. So we have to remember only common formula for units of K is nothing but concentration power 1 minus n into time inverse. N represent here order of the reaction. All of you here. Okay, let's see some competitive. He given like this equation and he is asking that write down the rate of reaction expression. Rate of reaction here writing means change in concentration by time. Change in concentration with respect to reactant is always indicated by minus. Or change in concentration of nitrogen by time change is equals to minus of change in concentration of oxygen by time change is equals to here coefficient is 2, but you have to take it as a reciprocal because always rate of reaction have to express per one more change. Is it any necessity to write the negative sign here? No, because it is a product. So 1 by 2 into change in concentration of NO by time change. This negative sign indicates which one? The rate of consumption or decomposition or disappearance. So it is nothing but a change in formation. Can I ask you one question? For example, you have